This evening we have Ryan Trinkle. He's a familiar face to many of us who come regularly. He's going to talk about a new library that he's written called Reflex, which is a FRP, or Functional Reactive Programming library. I have had the opportunity to use Reflex a little bit recently, and we used it for a pretty substantial project, and it was a really amazing experience. I have had a lot of fun using the library, and for me, getting into FRP and Reflex, I have a lot of the same feelings that I had when I started with Haskell. You have some same aha moments, and everything just seems to work the first time, which is really a cool feeling. So I'm looking forward to Ryan's talk tonight, and take it away, Ryan.
All right. Thanks, Doug. Can everyone hear me all right? Okay, great. Looks like my screensaver is a little too aggressive. All right, so my name is Ryan, and I'm going to be talking to you tonight about functional reactive programming. So I'm sure a lot of you have heard of functional reactive programming, and some of you may have even tried it. But I'd like to start off just by defining it. So you all know what functional programming is. You know, when you're using Haskell, we usually mean specifically pure functional programming when we say functional programming. And this is as distinct from functional programming in JavaScript, where it basically means that you have access to higher order combinators. In Haskell, we really mean that we're doing pure functional programming, which means that we're writing programs primarily using pure functions, which are functions that don't have any side effects. So it's really this side effect avoidance that is the underlying concept that we're going for with functional programming. The second thing in there is reactive programming. And what does that mean? Well, basically that means we're writing programs that react to their environment. They consume input over time, and they produce output over time. And there's you know, sort of an event loop style thing. That's one approach to doing it. Callbacks are another approach. There are a lot of different approaches to doing this, but basically reactive means the function is interacting with the world in real time. So functional reactive programming is writing programs that interact with the world using only, or as much as we can, pure functions. So this is basically the combination of the Haskell style approach and the real world needs of software applications. Now, all of you are here because you're interested in Haskell, and one of the things that makes Haskell so great is that purity gives us equational and local reasoning. And these are two things that really help us a lot when we're trying to construct software, understand software, and maintain software over time. Equational reasoning is the ability to reason about what programs are the same as what other programs. So this is really what underlies any kind of refactoring activity. We want to make a change to the code, and we want to be confident that it isn't going to change what the program actually does. So here we have an example. You know, everyone knows if you have something and you add it to itself, that's the same as multiplying by 2. And because we know that identity there, we can do these kinds of manipulations in our programs. Now, in an imperative language, or one that supports impure functions, x might be an expression that includes a call to a function that does practically anything. Maybe it does a database transaction. Maybe it increments a counter. Anyone who's worked with C macros is familiar with the situation that can arise when you use one of your macro arguments multiple times, and then suddenly someone passes in I++, and now you're incrementing their item twice rather than once, and it's very surprising. So purity is really critical to maintaining equational reasoning. And this is why it's so much easier to refactor Haskell programs than programs written in almost any other language. Local reasoning is a very related but distinct concept, which means that we can look at a piece of code and understand its meaning and what it's going to do in isolation, without looking at the rest of our program. This is really important because this is the key to reusing code. Code is only reusable in so much as it does not care about the context in which it's used. The more you care about the context in which you're used, the less different contexts you can be reused in. So Haskell, by using so many pure functions, functions that can't rely on a global state variable or doing I/O in the middle of their computation, really makes it much easier to reason locally about what programs do. And so we have a little example here for this one as well, which is basically that if I give you a function that doubles its argument, you know that every single time you run it, it's going to do exactly the same thing. If you pass in 3, you're always going to get 6. And this is something that lets us do cool stuff like memoization of functions. That just would be unthinkable for a function that wasn't susceptible to local reasoning. So this is really the essence of the value that we get out of Haskell. There are a lot of other advantages of Haskell as well, but for me, these are the most important ones. In my work at SchedgeMe and at other companies, I've been able to take huge code bases, shrink them down to much smaller Haskell code bases. I've been able to iterate very quickly, and I've been able to just get a lot of stuff done. This is what makes it so that we can go from prototype or even just concept into production really, really quickly. And that's where a lot of other languages get hung up. You might be able to rapidly prototype something in another language, but for me the real question is, how quickly can I get it to market? And that's where Haskell really shines. So there's one limitation on this in Haskell, which is that really everything I just said mostly applies to batch systems. And what's a batch system? A batch system is something that does big batch jobs. They take pretty much all of their input at the beginning, and they produce pretty much all of their output at the end. Anyone who's written a compiler in Haskell knows that it's beautiful. It's so much better than almost any other language around. A lot of my work has been on web API servers, and although they do lots of things at once and they stream to and from clients, at the end of the day, most API servers are getting an API request in its entirety, running the API request, whatever it needs to do with the database or that kind of stuff, and then producing all of the output and sending it to the client. Outside of video streaming and a few other things like that, that's what most REST APIs and such are doing. So really, these can be thought of as primarily batch systems. And this is a great match for the Haskell semantics, because a pure function is basically like a batch system. It takes its arguments, and then it produces its output. And what happens in between is side effect free. You can think of it as being a sort of black box. So that's great. The problem is, in the real world, we don't usually want to deal with batch systems. People don't usually think of compilers, people outside this room anyway, don't usually think of compilers as the most exciting kind of thing to work on. They want to work on user interfaces. They want to work on systems that interact with their environment, robots, and those things can be done in Haskell. But the way that we normally have to do them is by breaking down into the I/O monad, or some, maybe more constrained monad that we construct for ourselves for safety. But basically, we're writing in an imperative language that's just a domain-specific imperative language in Haskell. Now, that happens to be my favorite imperative language, but it's still basically imperative programming. So the question is, how can we get away from this? Functional reactive programming is the way to get pure functional systems into the real world. This is how we can do interactive systems using all of the techniques that we know and love from Haskell-based batch systems. So web pages, user interfaces, robotics, audio synthesizers, that kind of stuff has to react to its input in real time. And that's, what we'd really like to be able to do is not have to resort to the I/O monad in order to write these complex real-time interactive systems. So what is Reflex? Reflex is two things. It's a semantics for FRP, a specification for what FRP means, and it's also my implementation of that semantics. Reflex works with GHC and GHCJS, so you can produce programs that will run in any environment supported by either of those compilers. That means x86 native binaries. It also means Android, ARM, iOS binaries, which is a fantastic project that's been open source for a couple of years now. And it also can be compiled to JavaScript, and it can be run in a browser that way. So pretty much any target that you might have is supported. My focus at the time with Reflex is on Reflex Dom, which is a library for building document object model, in other words, web pages. And it can build anything. It can build a single page app. It can build components for inclusion in other apps. It even runs in Node.js, so you could integrate it into a Node.js server. Or you could use it to build pretty much anything on the web can be built with this. All right, so let's get to the meat of this. I'm going to go through an example, which is going to show you how to build a Twitter client using Reflex. All right, so here's our first very simple example. All this is a text box together with a display of the contents of that text box. So if I type some text, it's going to show up right next to the text box. Now, we're using a couple of things here. The first thing is a text area. So this text area function is going to do two things. One, it's going to place a text area into the DOM. This works just like Blaze Builder or Lucid or any of the other HTML building libraries you may have used. But unlike them, it also returns a value. And the value it returns is a text area object. And this is going to contain all of the dynamic outputs of the text area. We also have to give it an argument because text areas are pretty complex things. In this case, we're using def to give it the default value. But there are a lot of different attributes that you can modify of the text area, and we'll get into that later. Then, once we've got the text box built, we're going to extract the value from it, and then we're just going to put that right into this dyn text. And just like the text area, that's going to put an element into the DOM, most specifically a text node. And it's going to always keep it updated. So whenever I type into this text box, it's going to cause an event to fire in the FRP system, which will cause this to update. So no matter what happens, this text is always going to be displaying the current value of the tweet box. And you can see that right in the code. Now, I'm going to go through a bunch of these slides. Please feel free to interrupt me if you have any questions. Does this slide look good to everyone? All right. Okay, so tweets, obviously, are limited to 140 characters. So let's add that constraint in. All we have to do that is modify the default argument to the text area. So we can just use some lens functions and the assignment operator to assign to the attributes field of the text area configuration object. So in this case, the interesting thing about the attributes is that they can change over time. So you may need to add a CSS style, for example, if the value in the text box becomes invalid. And in that case, you would need to change the attribute from whatever the normal state is to the invalid state, which might make it have a red background or something like that. For what we're doing right now, we don't need to actually change it dynamically, so we use this function called const_dyn, and that just takes a regular value, in this case a mapping from the key to the value, and it turns it into a dynamic that never changes. Now, this little equal colon operator, that's just data.map.singleton. Nothing fancy going on there. Attributes are just data.maps from string to string. All right, and so the next part is exactly the same. So let's make sure this works. Okay, so I'm going to assume that was 140 characters. This is just using the inbuilt DOM capabilities. All right. So the next thing we want to do is give the user some kind of feedback about this. Obviously, stopping them at 140 is great, but it would be nice if they knew when they were getting close. So now what we're going to do is take that value and get its length and show them that. So this works like this. All right, get to 140, and you can go back down. So this is pretty easy to do too. We get the value out of the tweet box just like before, but this time we need to map a function over it. So we use mapDyn, which is just going to construct a new dynamic value whose value is always going to be equal to the length of whatever is in the tweet box. So whenever that changes, whenever the user types into the tweet box, it's going to change the value, and then that will change the length, and then that's going to go into this display function. And display is just the FRP version of print. So you would print something to just show it and then output that to the console. And in this case, you can use display to put anything that's showable right into the DOM and keep it live. And then text here is just how we insert static text into the DOM. Nothing fancy there. All right. So the next thing we want to do is actually give the user the ability to send their tweet somewhere. So for that, we're going to add a button. Now, to add a button, we happen to have a function button with icon. And this is just going to construct the button that you see here. And I'll show you how this works. You can just type a test in there, click tweet, and then it appears down here. So let's take a look at how that works. The button takes an icon, and it's just using font awesome for that. And it takes some text, and it produces an event with unit inside. So this is an event that just occurs sometimes. Now, there are a lot of different ways that FRP systems approach this. In the semantics that I use, events are things that occur sometimes. And whenever they occur, they have a value. In this case, it's just unit. But they don't have any value whenever they aren't occurring. So there's actually just nothing inside. And so what's going to happen here is anytime the user clicks the tweet button, it's going to cause that event to occur, or what we usually say is to fire. And that's just like what would happen if you attached a callback to it. But as you'll see, the complexity stays way simpler than using callbacks. So that is the Font Awesome Twitter icon. And so that's just an I element with a CSS class that looks up that particular character from the Font Awesome library. Yep. All right. So we take that tweet button, and it's only got a unit inside, and that's not terribly useful. So what we need to do next is actually give it the correct value, which in this case is the value of the tweet. So we use this function called tag. And you can think of it like the event is running by, and it just grabs this value. And the value it's going to grab is the current value of the tweet box. And what current does is takes this dynamic, turns it into a behavior, and then tag can pick up, it can sample that behavior. So now you've seen the two basic primitive types of reflex, event and behavior. And events are things that occur sometimes, and they'll notify you when they occur. And behaviors are things that you can ask for their value whenever you want. Dynamics are actually just a combination of those two ideas. They're a value that can change, you can ask it its value, and you can also be notified when its value changes. So tag is just going to pick up that current value from the tweet box and replace the value of the event with that value. So we return that from this do block, and that means that new tweet is just going to be an event with a string inside. And the string is going to be whatever the tweet was at the time. Now, down here, we can take that event, and we need to put it on the screen. But you can't put an event on the screen, because it only exists sometimes. So what we need to do is turn it back into something dynamic. And for that, we use holdDyn. And what holdDyn does is it takes an initial value, it takes an event, and it produces a dynamic from that. And what's going to happen is the initial value will be the initial value of the dynamic, and then whenever the event fires, it's going to replace the value inside the dynamic. So latest tweet is always going to contain whatever the user most recently tried to tweet, or the empty string if they haven't tried anything yet. Then we just put some static text down, and like you've seen before, put a dyn text there, and this is how it looks. All right, any questions? Go ahead. Yeah, that's a good question. So in Reflex, there's no way to ask a behavior to notify you when it changes. And the way the DOM works, we can't sort of poll it, certainly not efficiently. So we need to actually push any changes that are made directly into the DOM. And so in order to do that, we need an event. And that's the difference between a dynamic and a behavior. So in any Reflex DOM code, you're going to see a whole lot of dynamics, because it's very common that we need to push that data into the DOM proactively. If you were writing a OpenGL application, it might be much more heavily behavior-based, because generally OpenGL kind of pulls the scene graph once per frame, and it doesn't need to be notified that something has changed. In fact, it's probably more efficient not to notify it. So that's really just an artifact of the particular domain that we're addressing here. Does that answer your question? Great. Any others? Brian? Yeah. Yeah, that's right. So we've basically just wrapped up the display from the previous slide and put it into a function here. Yeah, and so just like in Blaze or Lucid, the order in which things are listed in your do block is going to be the order that they occur in the DOM. All right. Go ahead. Well, Blaze and Lucid are really for creating static DOM. They don't have any facility for updating or for getting the value out of something. Basically, Blaze is essentially a monoid acting like a monad, meaning that it's really just like a very nice and useful way of constructing a value, but it doesn't have any way of getting stuff back out of it. Yep. All right. Let's move on. Okay. So the next thing we want to do is clear the box once the user tweets. Obviously, they need to be ready to tweet again as soon as possible. So how are we going to do this? Well, here's where we have to introduce a very interesting and useful concept, which is a recursive do block. And what this is going to do, this is using the regular Haskell extension recursive do, and this lets us refer to variables before they're actually defined. So you can see that on this line, number 5, I'm binding tweet button, and then I'm actually referring to it on line 4. And so what's going to happen here is The existing flow, where we take the tweet button, we tag the value onto it, and then we put it into the dyn text, that's going to stay unchanged. But we're also going to add another attribute to the text area config, which is the set value attribute. Now, this is where the difference between FRP and callbacks starts to become really apparent. In FRP, the strict data flow and side effect free nature mean that you have to have any data flowing into something is going to have to be an argument to it. So we can't take this tweet box and sort of push data into it. We can't just start messing with it after the fact. We have to supply this set value parameter as an argument when we construct it. And it turns out that this makes it much easier to reason about how the program works. So set value is just another built-in argument to text area. And what we're going to do is we're going to fill it in with an event, which is just going to be the tweet button event, f-mapped so that its contents are always the empty string. So we just throw away the unit that was inside of it, replace it with an empty string. And so those of you who are familiar with this stuff are going to notice that events are functors. That comes in really handy in a lot of situations. Okay, so that's pretty much it. Let's take a look at how it works. Put that in there, and then we're ready to, to tweet again. But there's one thing that's not ideal about this, which is if we click tweet while it's empty, we're going to clear the status. And as anyone who uses Twitter knows, that's not actually allowed. So let's take a look at what we need to do to stop that. Turns out it's actually super easy. All we have to do is add this little bit here, and all that's going to do is say only allow new tweet events where the contents are not the empty string. And that's it. All right. Now, obviously, if you could only post your most recent status, that's not really Twitter. So let's build a little bit more of Twitter. Let's actually keep old tweets around. We're going to build now a reverse chronological order list of all the tweets that you've written. And that's another really simple change. All we have to do is take that hold dyn that was down here and replace it with fold dyn. And what fold dyn does, it's a lot like a fold L, except that instead of folding from left to right, it folds from the past to the future. So by folding through time, we can create these state-carrying objects. And so all we have to do is supply a combining function, the cons function from list, as well as the initial empty list, and then the same event that we were supplying before. So let's see how that works. Well, first of all, so you can see the empty list down here. Might be a little bit small, but if I try to tweet with an empty box, that's not going to do anything. But now I can write 1. All right, it went down there. 2. All right, 3. So that was simple. All right, now let's do something real. I'm not going to go through all the code for this, but we have a little OAuth integration here. So I'm going to click authorize. All right, the Wi-Fi is not as fast as it could be. All right, that's looking a lot better. All right, so now we've got OAuth. Great. So let's take a look at what we've done here. So we have this Twitter authorize button, which we just abstracted into a little widget there. And what it's going to produce is a dynamic of maybe credential. So when it's not authorized, it'll be nothing. And after we've authorized and we've got this little check mark, then it's actually going to have Twitter credentials in it. Now, we're going to use that to basically set that disabled state. You might have noticed that this text box had some little hash marks over it before. And basically that's because we were dynamically setting the attributes, like I mentioned before. So you can see that we're setting attributes to tweetbox adders, and tweetbox adders is just defined, again, by using mapdyn to translate this dynamic authorized state into our final list. So what happens is the creds come in. We use forDyn, which is just flip of mapdyn, to map this function over it. If it's nothing, then we set the disabled state. Obviously, the hatch marks were CSS based. And all this code, by the way, is exactly the code that is running in the widgets. So the only thing that you're not seeing here are the functions that we've abstracted out and the CSS. So if there are no credentials, we're going to set disabled equals true. Otherwise, we're going to just supply an empty map. And then we're going to insert the max length argument into that as well before we send it into the text area's attributes. So now we're actually making full use of the fact that attributes are dynamic. We haven't hooked it up, though, yet to the actual Twitter submission. So let's do that. So let's just see how this works. All right, let's cross our fingers. All right, so that went up on Twitter, and you can see that it also came up in my little live feed at the bottom here. So any of you can go on Twitter now, look at Ryan Trinkle, and it should be there. Great. All right, so let's take a look at how we did this. So we need to do a couple of things. First, we've got the new tweet coming in from our tweet widget. So we've abstracted this whole area here, everything from characters and up into the tweet widget. So that's going to produce our new tweet event. We don't have to worry about the rest of it anymore. And then what we need to do is take the new tweet and attach the current credentials to it. So whenever the user hits tweet, it's going to look up the current value of the credentials, and it's going to pair that up with it. So this is a little bit like tag, which we saw earlier, but instead of throwing away the value of the event, in this case we need it, so we use attach instead of tag. So that's going to produce an event that has credentials and a string inside. We send that into toTweetRequest, which I'm not going to show you the hairy details of, but basically it takes the string and the credentials and turns it into an XML HTTP request. It also, if there are no credentials, it will throw away. It'll return nothing. And then we use fmap maybe to just discard any events whose value is nothing. So then what we're going to have here is an event with an XHR inside. And it's only going to have the valid ones. So what we need to do is send that into perform request async. And this is something provided by Reflex Dom. And all you do is you give it an event with an XHR request inside. And it produces an XHR response event whenever your request completes. Now obviously if you need more complex error handling, there are functions for that as well. But this is sort of the basic one for everyday use. Then once the response comes back, we decode it, and then we hold it. And so in this case, the latest tweet dyn is actually not based on just what the user clicked. It's actually based on what Twitter has sent us back. So they're going to see a status here that is only going to appear if their tweet was successfully posted. All right, so that's basically that. Now, we can also show a live stream. This is using WebSockets as well as the Twitter API. And so you can see that it's showing the tweet that I posted. And it's also showing it down here. This is different code, but it's coming from the same stream. And so if you guys tweet at me, you should see your tweets appear right here. Might be a slightly biased party there. All right, so how do we actually do this? So in this case, what we're doing is getting updated from the credentials. And what this is the event that's going to fire whenever the credentials change. As I said before, dynamic values consist of an event and a behavior. So updated gets the event part out. Then we're going to fmap maybe the identity function, and that's just because we want to throw away any updates that are changing the credentials to not present. So this is only going to fire when we have valid credentials, and then we're going to call start stream. And start stream is going to open a WebSocket connection and return an event that fires whenever we get a new status. Then we use the same fold dyn that we used before to collect up all the tweets that we get from the stream. And then we put it into a div here. And as you can see, this talk has been a little bit light on any kind of styling stuff, but there are primitives for all that kind of stuff as well. Div class is just going to create a div with the class stream here. Simple list is a really great combinator we have. The type is a little bit more complex than some of the other ones, but basically it takes a dynamic list, which is exactly what we just built, and it takes a function that's going to render each element of the list, and then it turns all of that into a little DOM widget for you. So that takes away any necessary anything that you would need to do to manage that yourself. It's all handled automatically. I see that it's already begun. Maybe this was a mistake. All right. Great. So, here we're going to show the username. This is pretty much exactly what you'd expect. This is what's being rendered here. Good stuff. All right. Any questions so far? Okay, great. I may need to. I may need to do that before the next talk. All right. So the next thing we're going to do is add a whole bunch more styles. We want to have it look a lot nicer than it did before. We can make an element with a class. So this is going to make a UL element here. It's going to have FAUL, which is going to tell FontAwesome to do its stuff on this list. And then anytime you've got L or div or any of these elements that can have nested children, that's just going to be the last argument. And so then you can put a do block at the end of that. All right. So obviously, Twitter front ends are not the only thing that we make with Reflex. There are a couple of other things that I've made and that others have made so far. Of course, every front-end framework has to have a to-do MVC implementation. So, got one of those. And you can just, make as many things as you need. You can check them off, filter. You can clear the completed ones, go back to all, select all. It's pretty much exactly what you'd expect. And that's all just about 180 lines of code, including imports. So it's very simple, very legible, and yeah, pretty simple. Another app that Ali, my partner at Obsidian Systems, and I built is called Redline. And we built this in a 48-hour hackathon. And basically what this lets you do is legal document collaboration. So this is a fully real-time application for commenting on and suggesting changes to contracts. And it basically lets lawyers communicate both internally within their law firm. That's where the private comments go on the left. And it also lets them make public comments, which go to their counterparties. So both sides of a transaction can use this application to communicate efficiently, both in-house, maybe even with their own clients, and with the counterparty who they may not want to reveal all the information to about their negotiating position. And the great thing about building this with Reflex was that it was super easy for us to make everything live update. So, you can see strike-throughs and underlines and comments, and all of these will pop in instantly. So if somebody has this document open and they're working with someone or even have them on the phone, they can immediately see any changes someone else is making. And similarly, this is one of the first things I made with Reflex, and it was almost a surprise when we implemented the comment display, and it was just an instant messenger window. We didn't have to do anything fancy. We just wrote the most dead simple displaying a list of comments we could make, and it was automatically chat. Another app that we've built that takes great advantage of the real-time nature of all this stuff is called Prasava. It's built for courier services who want to keep track of all the jobs they're doing, as well as where all of their employees are, along their routes. And so basically what this does is it has obviously a database of jobs, and all of that, of course, updates in real time. But also it's got an integrated Google Map. And it was super easy to integrate Google Maps with the GHCJS code. That's obviously something we wouldn't want to build ourselves. And all these little pins that you see on the map can move around as jobs are created and finished, and as people drive around using GPS, because there's also a phone app of this, which also runs in the phone browser with Reflex, and it sends GPS coordinates in real time. I've had the privilege of working with the guys at Stone recently to help use FRP for their online data analytics platform. This is a really complex application that gives a lot of great functionality for users to explore their data sets. It does a ton of cloud computing to get them their results really fast, even with huge data sets. And so with Reflex, we were able to cut their front-end code base by about 50% in terms of code, and it was already in Haskell too. It was just not FRP. And it gives a better user experience. It's much easier to maintain. They can iterate more quickly to add new features and to serve their clients' needs. So that was a really great experience as well. Of course, Obsidian Systems, my company's website, is all built in Reflex. That's what it looks like. And this presentation is a Reflex app. It was built with Reflex Dom, Impress.js, and a Snap backend. All right, so that's the end of the first half. You can try it out. I've got a repository set up here that will make setup a breeze. It handles installing GHCJS and everything else you need to start building Reflex apps, and that's all you got to run. So I guess now you should get back on the Wi-Fi and really overwhelm it with downloads. Thanks, everyone.